All right, this is video 2. This is going to cover collision systems, so all of this stuff, whoa, up to here. Yeah, let me pull up my thing. Okay, so first off is just an overall diagram of the collision system. Let me move this a little bit. So we have Collision Manager. Collision Manager has a list of test commands. There's the 3 different kinds of test commands: self command, pair command, and terrain command. These, when you create when you set 2 things to collide together, they create the dispatches, which have the pointers to the different collidable groups, so you know what to execute when things collide. In terms of collidables, they have the registration and deregistration commands. And then each collidable has a collision volume. It has a default B-sphere and a collision volume that the user chooses. Here's the diagram for collision volumes. So I have B-sphere as its own thing, but then OBB and AABB are both children of the bounding box base, so they have a lot of shared data, and that way you can easily do intersection between AABB and OBB using an OBB test. So hopefully that makes sense. Gonna switch over to the collidable class. So, like I said, it has an internal B-sphere. All of them have a B-sphere, and then the user can pick their own collision volume, which could be B-sphere or it could be the other 2. You can access these with the getters, get collision volume or get B-sphere. In terms of like setting this up, pretty easy. For the cottage, for instance, you set your collidable group, you register for collision, you set your collider model, and then updating the collision data. So going into collision volumes a bit more, this is the base class collision volume. It has all of the parts of the visitor pattern that I'll talk about a bit later, and the main thing it has is compute data that each of the different child classes implement. So for a B-sphere, all a B-sphere needs is a center and a radius, and then you update that in the compute data right here. And then it implements all the different collisions. So B-sphere other goes to the intersect visit, and then that propagates down to B-sphere AABB, or B-sphere OBB, which calls the math function, which I'll talk about a little later. So that is B-sphere. Bounding box base has all of this stuff that all the boxes need. For a AABB specifically, the world matrix is always going to be the identity matrix, so you set that at the beginning, and then you update everything else as needed, and go in here and update everything, the center and the scaling factor squared. For OBB, your half diagonal is always going to be the same, because you set, the box right at the beginning, but then you're updating the world and everything else. So that's how you update all of that. For the visitor pattern, I already described pretty well. Each of the child collision volumes has all of the different pairs of collisions that you can have. And then they call just these static math tools functions. So basically, where's my math tools? Math tools right here has the intersection for everything that you need. So B-sphere, AAB, ABB, blah, 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 you can read. And then bounding box. And all the math is in there, so those get called. Right. Next is collidable groups. So collidable groups, the new thing we did this quarter is that every collidable group has its own group AABB, so it's literally just its own collision volume for this group. you can update the group AABB and access it. For the updating, this is basically summing together all the different AABBs. So I have this math tool called sum, which will sum, basically get the rough AABB of an object based on its B-sphere. So I have a compute data function that takes a B-sphere and returns an AABB. And then you sum all of those together to get the group AABB. The collision manager, let me find it really quick. The collision manager in the process elements, which is called every frame, first it computes all the group AABBs and then it does the tests. So this just loops through all of the active collision groups, collidable groups, and updates the group AABB. Yes. Then for collision testing, the group AABB is used in the tiered collision testing. So starting with the pair command, when you execute a pair command, you first test if the group AABBs intersect. Then you test if, for each objects in the collidable group, you test if the B-sphere interacts with the group 2 AABB. If that goes through, then you loop through and test all the B-spheres against each other. So test if this B-sphere intersects with this B-sphere, because that test is cheaper. And then finally, if those also intersect, then you do the final test, which is their actual collision volumes, whether they intersect. So for all of these, you just do early out if they fail. The only thing in here is the visualization, but you just kick out. For the self command, since they're in the same group, you skip the first two steps and you just start with the B-spheres. So you test all the B-spheres against each other. If those intersect, then you test their actual collision volumes. Right, and then the third test is terrain collision test, which is right here, but I'm going to talk about that later when I talk about terrain. So, just to show that this works, I'm going to run this. I have a scene, kind of a lot going on, but basically these frigates, I forget which volume types these have, but this guy has an OBB, and then this cottage has an AAB, no, this cottage has a B-sphere, this cottage has a AABB, and this one has an OBB. These might be switched. But anyway, so you can see that since the overall group AABBs aren't intersecting, they're green. As soon as it collides, however, then you have to start testing for the B-spheres. So these guys are good, so they're pink, but since this guy does intersect with the group, it's purple, and since all of these intersect with the group, they are also purple. If I go close to one of these, then you can see that like right here, so this is OBB. The B-spheres are intersecting, so they turn yellow, but since the actual collision volumes aren't intersecting, there's still no collision. And then if I go a bit further, then they turn red and there is a collision. So yeah, shown this off before, but just wanted to be thorough. Yes. Self-command works as well. Let me show that really quick. So I'm not going to do the pair, I'm just going to do the self with the frigate. And there's no group stuff going on because that doesn't really help us anymore. But I can go up and do sorry. So if I just do the B-sphere, if I just do B-sphere intersection, if I can get it. Yeah, so now just the B-spheres are intersecting, but the actual collisions are still blue, or the actual volumes are still blue. And then if I go all the way, then they actually intersect. So that is all the new collision stuff from this quarter, except terrain, which I will talk about in a second.